Okay, dear students, we will continue lessons Higher Mathematics 2, Practice 2. Practice on limits and continuity in higher dimensions. We just saw the example in the lecture part, which is the example 1, and just recap this information. We have to calculate this limit, and we have to plug in instead of x 0, instead of y the number 1, just 0 minus 1, 0 times 1 plus 3, and here 0 squared times 1 plus 5 times 0 times 1 minus 1 cubed, and which is this expression, and calculate this expression, simplify, get negative 3. In this case also 3 instead of x, negative 4 instead of y, just 3 squared plus negative 4 squared, which is of course under the square root, and here also 3 squared will be 9 plus 16, 25, and we got 5. The example 2, in this example we've multiplied the both parts of the fraction, which is numerator and the denominator, with the positive one, with this one. We have to multiply this kind of expression to the both part with positive, because we have to use the taking from irrationality. There is irrational thing on the denominator, just cut off that. In order to do this, we have to multiply both parts, this expression. And if I multiply this to denominator, I will get here x minus y. According to the rule, a squared minus b squared is equals to a minus b, a plus b. According to this rule, I will get here x minus y. And on the numerator, I will get, just take x outside of parentheses, x minus y, square root of x, plus square root of y. So that expression. Go to the next part, the expression just now I've calculated x minus y, x minus y. There again, we got this expression, just plug in numbers, 0, 0. The answer is 0. We can cancel the factor x minus y because the patch y equals to x is not in the domain of the given function. It's not in the domain of the given function, so we can cancel that. In other case, we can't cancel the factor, which is 0. So the next example told to us to calculate the limit, which is find the limit when the point xy tends to 0 and if it exists. We first observe that along the line x equals to 0, the function always has value 0 when y is not equal to 0. Likewise, along the line y equals to 0, the function has value 0 provided x is not equals to 0. So if the limit does exist as the point xy approach to point 0, 0, the value of the limit must be 0. To see if this is true, we apply the definition of the limit from the theory part, which is lecture 2. And in this case, we may see this is the point O, and it's approaching to this point from that part maybe, or from this part, or from that part. We want to calculate the limit and we can see from this graph that the function must have any value at this point, because we can see there is something at the point which we call origin. And we use the theorem. Let me take the epsilon positive, and it's given to us by arbitrary any small number. We want to find the delta positive such that these two expression holds. Or if I simplify this first expression, the expression minus 0, so I don't have to write that, and it was in the absolute value signs, between absolute value signs. And if I look carefully here, I will see x squared, and then plus, and then y squared. So this is always positive. I don't need absolute value sign here. And on the numerator also, I have x squared and 4. There are also positive numbers, just the x. So x is in the absolute value, and this expression must be smaller than epsilon. Whenever the expression is between 0 and delta. Since y squared smaller than or equal to x squared y squared, where did I got this? Because I know y squared can be equal to itself, but if I add any number, maybe small or bigger number, which is x squared, and it's also positive, the expression on the right side will be the greater than or maybe equal to y squared, which is if x squared is 0, they will be equal to each other. If x squared is not 0, it's always greater than. So from this one we have that the expression smaller than or equal to 4x, and the absolute value of x is square root of x squared, because when we cut this square root and the square, we'll get absolute value of x. We don't know is it positive or negative number, so we always write absolute value of x. And from that one we also go that the square root of x squared plus y squared is greater than square root of x squared. Of course, if y squared is not 0, it's always greater than that expression. And here we use this one because when we divide y squared by x squared plus y squared, we'll get a number smaller than 1. Only in one case it will be 1, when x squared is 0, which is x is 0. So if we choose delta like epsilon of 4 and let this expression holds, it follows from the definition that the limit of function is 0. But we cannot plug in here these zeros. If we plug in 0 here, it will be 0 over 0. So it's undefined, we can't calculate. But using theorem, which is the definition of the limit, we can check that this limit exists and its value is 0. The next one is example 4. It says we have a function f of xy, which is y over x, and we have 0.00. If this limit exists or not. The domain of f does not include the y-axis. So we do not consider any points xy where x equals to 0 in the approach toward the origin 0 along the x-axis. The value of the function is f of x and 0, which is 0 for all x is not 0. So if the limit does exist as point xy tends to 0, the value of the limit must be 0. On the other hand, along the line y equals to x, the value of the function is f of x and x, which is the x divided by x gives us number 1 for all x is not equal to 0. That is the function f approaches the value 1 along the line y equals to x. This means that for every disk of radius d centered at 0, 0, the disk will contain points x and 0 on the x-axis where the value of function is 0, and also points x along the line y equals to x where the value of the function is 1. So no matter how small we choose delta as the radius of disk, this is not ordinary d, it is delta, yeah. Of disk and figure, there will be points within the disk for which the function values differ by 1. Therefore, the limit cannot exist because we can take epsilon to be any number less than 1 in the limit definition and deny that L equals to 0 or 1 or any other real number. The limit does not exist because we have different limiting values along different paths approaching the point 0. Now we have some good exercises to do and to check double variable functions. So it's easy to calculate them. If you want, just pause the video and try to calculate on your notebook. I will try to check this exercise after calculating on your notebook. You may check here. So let me start from the first one. It says plug in 0 instead of x, plug in 0 instead of y. Okay, if I plug in 0, 3 times 0 squared minus 0 squared plus 5 over 0 squared plus 0 squared plus 2. So 3 times 0 squared becomes 0, 0 minus 0 plus 5, 0 plus 0 plus 2. So on the numerator I will get 5, the denominator gives me 2. This is the answer. So check the first exercise. If it's true, go for second one. Plug in 2 instead of x, plug in -3 instead of y. Okay, 1 over 2 plus 1 over -3 squared. And this gives me 1 over 2 minus 1 over 3 squared, and I have to find the common denominator, which will be 6 in my case. 6 over 2 gives me 3 times 1 is 3 minus 6 divided by 3 gives me 2. 2 times 1 gives me 2 squared. So 1 over 6 squared. 1 squared is 1, 6 squared is 36. Okay, check the second exercise. If it's true, if it's correct, go for third one. Equals to, instead of x, 0, instead of y, ln 2. E to the 0 minus ln 2. This gives me e to the negative ln 2. So do you know how to calculate this one? This is the expression equals to 1. Calculate this one. This is the expression equals to 1 over e to the ln 2. If you have this kind of expression a to from the logarithm, I will write here with different color, like a log a x equals to x. I'll use that rule. I will use that rule, so it will be 1 over 2. Okay, check the third one. Go for fourth exercise, equals to, write down 1 over 27 instead of x, and write down pi cube instead of y. Cosine cube root of 1 over 27 times pi cube equals to, again, cosine cube root of pi cube over 27 is 3 cube equals to cosine cube root of pi over 3 cube. Now this cube and cube root are gone. I will get cosine pi over 3. Cosine pi over 3 is 60 degrees. What is the value of cosine at 60 degrees? It's 1 over 2. Check the first exercise also. If it's correct, go for next page. Now we have to find the limits in exercise by rewriting the fractions first. We have to rewrite these fractions. Why? Because if we just plug in these numbers here, maybe we will get some bad, not beautiful expression. So let's rewrite them. Start from the first one, equals to 1 instead of x, 1 instead of y. Okay. If you look carefully on the numerator, you will see some formula. I can write limit xy tends to 1 and 1. X is not equal to y. Numerator x minus y is squared. X minus y equals to this squared, and x minus y are gone. I will get limit xy tends to 1 and 1. X is not equal to y. X minus y. So now I can I don't have to write this one because I don't have denominator now. Just plug in ones. 1 minus 1 gives me 0. Okay. And exercise 2 says, let me take another color now. In the exercise 2, this expression and that expression, find something to rewrite this expression. Xy tends to 2 and -4. X is not equal to -4. And y plus 4 over, here let me take x squared outside of parentheses, y plus 4, and let me take -x, y plus 4 equals to limit x and y tends to 2 and -4, y plus 4 in the parentheses, x squared minus x, y plus 4 here, equals to y plus 4 again. I will get limit x, y. Next, if I plug in number 2 here, 2 squared is 4, 4 minus 2 is 2, that 1 over 2. And you also have to calculate the limits in exercise 3 and exercise 4 in this way. And there are some other limits which are the triple variable functions, triple, x, y, and z. The first one seems easy, equals to limit. I don't need limit, just calculate this one. 1 instead of x, 3 instead of y, 4 instead of z. 1 over 1 plus 1 over 3 plus 1 over 4. Common denominator will be 12. 12 over 2, 1 gives me 12 itself, plus 4 plus 3, 7, 19 over 12. Or maybe 1.1.1.127. Yeah, this is how we calculate the limits of triple variable functions. In this case also just plug in pi instead of sine x, pi instead of cosine y, pi instead of secant z. Not sine and cosine, just instead of x, y, and z. Sine squared pi plus cosine squared pi plus secants squared 0. So just calculate these values. What is the value of sine at pi, cosine, and secants? Just calculate their squares and get the answer. The same for the third function. And in this exercise, function for continuity, at what points x, y in the plane are the functions in exercise is continuous. So we know the sine function, I know the graph of sine function, it's continuous everywhere. At point 0 it's 0, at point 90 it was 1, so the sine function's graph is like this. It's continuous everywhere, x and y. This is the sine function's graph was like this. We also call that sinusoid. And how to check this? First one. It must be, we know how to check it at point, but we know the sine function is continuous everywhere. So let's just check if there are any square root, any fractions like denominator or other kind of things. I think it's clear sine function is continuous everywhere. Continuous everywhere in the plane, not in the line, in the plane, because we have plane now. We have to take point from here, which is x and y. So in the plane. Second function, x plus y over x minus y. This expression is not continuous at point when x minus y is 0, which is x equals to y. So it should not be 0. It should not be 0. It should not be equal to x. What will I write? Continuous in the plane except when x equals to y. And the third one, sine 1 over xy. When xy equals to 0, it's undefined, so xy is not 0. The same was continuous except xy equals to 0. For the first one, we have to find the zeros of the denominator, which is x squared minus 3x plus 2 equals to 0. Now use the White theorem, and we can, I don't need this. use the White theorem. Now we can write that the x minus 1 and x minus 2 minus 1 and x minus 2 equals to 0. So x is not equal to 1, x is not equal to 2. Exercise 4 continues. Everywhere in the plane except when x equals to 1 and x equals to 2. In all other cases, these functions are continuous. We also can check the continuity for the functions in space which has 3 variables x, y, and z. That kind of functions we can check their continuity. For the first function, it's continuous everywhere in the space. Continuous everywhere in the space. The second one, x, y, z, must be positive. In all other cases, it's continuous. For this one, z is not equal to 0. For that one, y is not equal to 0. Z can be 0, or they are not equal to 0 at the same time. Y and z can be equal to 0 at the same time. In all other cases, they are continuous, and this one, z minus square root of x. So yeah, this is not equal to 0, which gives us z is not equal to square root of x squared plus y squared. If these conditions are all following our given functions are continuous. Good luck, guys. Try to calculate all of these exercises and some more exercises from Thomas' calculus book in order to